Reviewing for the pre-calc final, and this is problem 31. This is off the packet, by the way, and we're about 2/3 of the way through the packet. Odd, even, or neither. Do you remember that odd symmetry has a reflection through the origin? Like I take that spot right there. I go through the origin, and there should be a spot on the other side. There isn't one. So clearly this is not odd. Even symmetry. Even symmetry goes like a parabola, for instance. It would run right down the middle of a parabola. So if there's one here, there'd be one over there, exactly like it. Is there symmetry across the y-axis here? If I go here, is there a spot exactly over there? No, it's missing. So not odd either. Okay. So then these can be a little tougher to like look at and try to figure out, is it odd or even? You might get fooled into thinking it's odd by going, okay, there's one here, and it goes like that. Okay, so it seems like it's odd symmetry, but really it's perfect line of symmetry on the y-axis, so that means that would be even symmetry. Again, this one could easily fool people, but if you check in any spot over here, if you reflect through through the origin, there's a spot on the other side. Pick this spot. Go through the origin. Is there a spot on the other side? Etc. Okay. So let's talk about horizontal and vertical asymptotes. Who tells you about the horizontals? Bob. Is it a Bob, Sob, or a Bot? And remember the rules for those? If you haven't already written them down, I write them off to the side. I would use this packet as your review notes, so you can scroll through them right before the test. Figure on bottom, y equals 0. Or if there's something on the outside, but notice none of these have like +5 on the outside. If they did, it would change the Bob to moving up 5, of course. Okay, and then this Sob is y equals a ratio of the lead coefficients. So here's one that's same on both. And then I find the lead coefficients. The lead coefficient here is a -1. The lead coefficient here is a -3. I take -1 divided by -3 then to get the horizontals. These are all the horizontal rules. And then the last one is bots. There's no bots. What does that mean about asymptotes? There's no asymptotes if it's a bot. Okay. How about the other kind of asymptotes, the vertical asymptotes? The vertical asymptotes come from the base. You just look down here and you see if there's anything down there that would cause your function to crash. And if there is, that's either an asymptote or it's a hole. How could it be a hole? If you had something like this, x plus 4, x plus 2 over x plus 2, this kind that cancels on top and bottom, that makes a hole. The kind that doesn't cancel, like let's say there was an extra x minus 5 down here. Now this one that I canceled off here, that one made a hole. This one right here is still there even after I canceled off holes. That's the asymptote kind. So this kind would make an asymptote at x equals 5. This would be a hole at x equals -2. All right, so let's just do one of these. Let's look at f. If you can factor it, you should. Everybody factor the top and bottom of f. We're doing 32f right now. You see why I encouraged people who could not handle basic factoring to leave early, because there's so much factoring in this class. First I encouraged them to try to remember it, but if after the review sessions they still weren't getting it, man, you got to know factoring for pre-calc. Okay, should have been x plus 2 and x minus 2. And down here, x and x. And then I got to figure out some way to make a 10. It's probably a 10 and a 1 or a 5 and a 2. And a 5 and a 2 can make a 3. So then I know it's a 5 and a 2. Putting in a 5 and a 2. Now I got to figure out which one's negative. If I want the middle term to be negative, you put the bigger number is negative. So there we go. And that means this would have two things, an asymptote and a hole. That one's the hole. So the hole's at x equals -2. The asymptote's right here at x equals 5. Now the other kind of asymptote is the one that Bob tells you. Bob tells you y's. and the y's are the horizontal asymptotes. Is this a bigger on bottom, bigger on top, or same on both? Same on both. Even though it's like longer on the bottom, the degree is the same on the top and the bottom, so it's same on both. And that's therefore a ratio, and it's a ratio of 1 to 1, so it's 1. There we go. This was the vertical. That was a hole, and therefore not a vertical. If remember, on a test like this, it would be asking you, if you followed the directions, you would just tell me what the asymptotes are. And -2, it would have been easy to think it was an asymptote, but it wasn't. It was a hole. So if you would have said x equals -2 was an asymptote, I'd have said wrong, because it was a hole. How is D? Oh, no, that you're reading the black. These are the notes on the side here. Okay. D is, well, let's do that one quick. The x equals 1's from the bottom, x equals 4. Is it a hole? Is there one like it on top? No. So it's an asymptote. That's the vertical. And the horizontal is the one Bob tells you about. Y's. And is this a, what's this? The same on both, right? And therefore y equals what? 3 over 1, which is 3. Yes? Okay, the bottom cannot factor, and therefore you cannot make zeros on the bottom, and therefore you can't crash the function, and therefore there's no asymptotes.
But there's still a horizontal.
Is there? Okay, so if there's a horizontal asymptote, what's the rules on that? Is this a bob, sob, or a bot? It's a bob, and therefore you got it. Y equals 0. So there's no x asymptotes. There's no vertical asymptotes, but there are horizontal ones. Bob would be telling you it's a bob. Y equals 0. All right, let's move on. The domain. Oh, wait, not just the domain. The domain of the function's inverse. Okay, so first of all, if I want to know the domain and range of an inverse, do not go figure out the inverse and then find the domain and range. You find the domain and range of the original one, and then just reverse them. So all I need to know is the domain and range of this guy. But really, it says find the domain of the inverse means I really just need to find the range of this original function. You get what I mean? Because we're going to reverse them. So if we find the range, it'll become the domain of its inverse. So the range of this, well, if I had a picture, which I do, it's the square root thing, which looks like this, except it's been moved right 3. So now I'm going to try it again, moved over to the right 3. Now what's the range of that puppy? Range is from low to high. It's from 0 to infinity. And if the range is from 0 to infinity on this guy, then the domain of its inverse would be the same thing. Domain of the inverse. 0 to infinity. Yes? Good question. Yes, it is a bracket. Thank you very much for catching me on that. It does touch 0, and therefore it is a bracket. Thank you. Okay, so basically, if they're asking you to find the domain of the inverse, you're going to find the range of all of these. So how the heck do you find a range when they're a fraction function like this? The range is not as easy as, like, you know, finding the domain where you look at what kills it. The range, you have to have a picture for it, and you won't have a picture for something like this. I don't even know what that looks like as a picture. So you need to use the horizontal asymptotes then. They tell you the range on this kind. Because the fraction functions go forever. They're the ones that kind of look like this. But they can't exist wherever their asymptotes are that go across. So we need the horizontal asymptotes. Once we find the horizontal asymptotes, it'll be everything except that. So the horizontal asymptote, again, I asked Bob about the horizontals, and he'll tell me the y's. Y equals, horizontal asymptote. Y, is this a, oh, this is the same on both, and therefore it's a ratio, and therefore it's y equals 1 over 1, or 1. So that means everything works except 1. So the range on this thing is all reals except, I'm going to say negative infinity to 1. Doesn't work at 1. And then 1 to infinity. So if that's the range of this guy, it's also the domain of its inverse, which is what we wanted. So this is now not only the range, it's the domain of the inverse. In case you had forgotten, the way to say inverse is f to the negative 1 of x. That's an inverse. That's like the notation for inverse. It's f to the negative 1. Okay, so let's move on to this page. Okay, so if something's even and it passes through this, well, you just make a little picture. 5, negative 10, it's like way down here, and it's even. If there's a dot here, there must be, if it's even, another dot over there that's just like it. So you could figure out logically what point that would have to be. All right, let's move on to communication. Use this interval to use interval notation to describe, oh, for Pete's sakes, interval notation is so easy. I hope that this wouldn't be an issue for you. How do I say that? Bigger than negative 3. I start with negative 3 and I go to infinity. So the interval notation just means it looks like that. It's super easy. Don't overthink those. Write the equation of the line in point slope form. Okay, so if we got many examples of this, so that implies you're definitely going to have one of these on the test. If you haven't learned this by now, shame on you. Top 20, I've done this with you forever. Y minus y1 equals m times x minus x sub 1. And if you find the slope between the two numbers, you're going to put it here. And then when you find a point, you pick one of these points. I'm going to pick that one. And I would put it here and here. Okay, so I'm going to show you one real quick. I'm going to, first of all, figure out the slope. The slope is going to be 3 minus the 5 over 4 minus the negative 4. And that's going to mean 3 minus 5 over 8. And that's going to be negative 2 over 8, which is negative 1/4. So my slope's negative 1/4. And my x and y I already have. Now here's my points. I need to put a point here, and I'll have it. And my point I'm choosing is the x is 4, so it goes here, and y is 3, so it goes here. And there's an example, a problem. That's 37A. Okay, again, total review. If you've been staying up with those top 20s, easy peasy points. All right, I got to keep moving. And you can always come back and ask me for questions, personal questions later at the very end when I'm done. All right, how is it different if it's a quadratic? It's the very same kind of thing, but the equation that you start with is different. It's y equals a x minus h squared plus k. That's the general form when it's a quadratic kind. So now I'm going to go stick in these points, that point and that point, to find this. It's kind of like finding the slope, but it's not the slope. It's the stretch factor. So I'm going to put in x is 1, y is 3. Y is 3, I put a 3 here. And then I'm going to put in the other one. Oh, wait a minute, I put that in the wrong spot. Do you get what I mean? I just used the vertex and put it in for the x and the y. The vertex is supposed to go here and here. So the vertex is x is 1, that means this right here is a 1, and its y is a 3, that means this is a 3. Do you get how the vertex goes right there? The 1 and the 3? Yes. Is that a question? Okay, I thought I had a question. All right, so anytime you put your hand up even slightly, I think it's a question. So the point here of x is 0 and y is 5 goes here and here. Now it's 5 equals a times 0 minus 1 is negative 1 squared plus 3. Negative 1 squared is, of course, 1, and 1a is just a, so 5 equals a plus 3. So a must equal 2. Have I solved it? No. I found a. Now I go back and rewrite this puppy, and except I know what a is. So I'm going to go y equals, a is 2 now, x minus h squared plus k. And I also know h and k. I knew them from the beginning. They're the vertex. So it's y equals 2, x minus, and the x of it is 1, and the y of it is 3, squared plus 3. There we go. So let's talk about limit notation for 39. Use limit notation to write the end behavior. Well, first of all, you got to know what the picture looks like. If I can factor it, I should. I can't factor that. So then I just kind of make a quick sketch of it. I can't factor it, so I'm not going to know exactly where the roots are. I know it has a y-intercept of 10, though, because the y-intercept is where x equals 0. Would cancel out these two spots. Okay, so x equals 10 is the, or sorry, y equals 10 is the y-intercept. Now I'm going to go figure out if its lead coefficient is a 6, that must mean that it's even, and therefore they're both up or they're both down. Since it's positive in the front of the lead coefficient, it must be up on the right. And if it's an even number, they must both be up. There we go. Now, I know it touches at 10. It could be going down here and up here. I don't know, but I know for sure it ends that way. And all that really matters is the ends, because we're writing limits for the ends. So here's a limit for this. Limit of the function as x approaches. Now, if I want the right end, that'd be this end. X is approaching infinity, and the y is the answer. And the y is, how high is it when it gets there? This is the height when it gets to here. So it's infinity. And then you could write the other end, limit on the left side. Limit of the function as x approaches negative infinity gives you this end. And that's also infinity because it's going up. Its height when it gets there is infinity. All right, these are only different because, like, I know where the roots are. I know it's going to touch at positive 1 and negative 2 and negative 3. And I know its lead coefficient, if I put this, this, and this together, would be y equals x to the third, and it's positive, so it's going up on the right. It wasn't bouncing anywhere, otherwise there would have been a squared here. So it's just cut throughs. Cut through, cut. Oh, I missed one. I'm going to do it in blue. Cut through, cut through, cut through. There we go. And it's odd degree. Its degree is 1, 1, 1. Makes a degree of 3. So it makes sense that it's going up on one side and down on the other. So now I got my picture. Now I can write my limits. All right, so these problems are kind of a combo deal. Do you remember the volcano? This is a volcano that's been shifted down 3 and 2 to the left. All right, let's move on. Got to keep flying here. Number 40, state the degree and list the zeros of the polynomial function. All right, the degree is, when it's factored, you have to add these. 3 plus 1 makes degree 4. Okay? Another way to think of it is, if you multiplied this all the way out, you'd have an x to the 4th in it. Therefore, it's degree 4. This, the zeros, means hopefully it's factored, and this is. That's x equals 0 is a 0. And what makes that 0? X minus 3 has to equal 0. So x must equal 3. There's my two zeros. State the multiplicity of each one. The MPY is a good abbreviation for multiplicity. The multiplicity of this one is what degree is on it? 1. The multiplicity of this guy is 3, because the degree on it is a 3. And the last thing is the end behavior at the zeros. At this 0 right here, it would cut through. A lot of you said cross through, and that's fine. I don't need a T at the end. And on this one, it's a triple. And do you remember that's not a bounce, it's a snake. What? This was a cut through. Oh, this one? You can't write cut through, or it would be a cut through. This is a snake. A snake is different than a cut through. Just to clarify, a cut through just passes through in any old way it wants to. The snake has to be going a certain way, and it looks like x to the third. It's like that. That is a triple root. That's called a snake. As opposed to that could be a cut through, or that actually looks like a snake. That could be a cut through. There's a lot of ways to cut through. There's only one way to snake through. Okay. Bounce is pretty obvious, I think. Describe how to transform f into g. All right, so that's just saying basically where did it get moved. So these are transformations like this one got moved 2 to the left, and I would call it a, is it a horizontal or vertical reflection? Here's a way to remember that. High-vo. It's horizontal if it's on the inside, and it's vertical if it's on the outside. There's nothing out here. There's like no like +5 or whatever, so it's no vertical action on the outside over there. But there is this. That's a vertical reflection. And if you have to think it through on x and y, then you make yourself this, and you go verticals like this, so it's over the x-axis. This kind, when the changes are happening up in the power, that's up by the x, that's inside with the x. This is outside, and that's also outside. These are VOs. They're vertical changes because they're on the outside. If there was something in there with the x, like it was a little x -3 or something, then it would be 3 to the right. The stuff that's inside with the x would be the high. And there's nothing happening with that x in there. So there's no horizontal action on this function. All right, moving on. Next page, problem 42. You got to be able to write a function like this that shows f of x with the following transformations. You know what? We should have said that that had a parent function. Like we should have told you what it was. So I'm just going to say f of x equals x squared is the parent. So you start with x squared, and then you do this stuff to it. How do I make a vertical stretch factor 3? I put a 3 there. How do I go right 2, for instance? I put a parenthesis around this and go -2. Now it's right 2, etc. So we should have told you a parent function to use on problem 42. All right. Got to write a note on that for myself here. Okay, let's go on to, basically this is again transformation stuff, you know, write this and up that, and this one's right 3 and down 4 and vertical stretch factor 2, that kind of stuff. All right. All right, this is where we're getting into some word problems. So they're hard to just say, here's how you do it. I can show you individual questions, but in general, you draw a picture of the thing, and then you try to figure out an equation that works with that thing. This one's a particularly tricky one because the picture isn't super obvious. But if it's on the curve, y equals x squared plus 1, you know at least it's a parabola that's been moved up 1, right? And there's a dot on there somewhere, and I'm just going to put a dot right there and say that's my point. And now it says express the distance from P to the origin as a function of x. That's like from here to here. I'm off a little bit, but okay. So now how do I get that? Well, you have to realize you really have a picture here. You have a triangle. And this is x, and this is y, and this is my distance that I need to figure out. Okay, I'm going to call it, I don't know, d. Okay, as a function of x. So now I've got my picture. I've labeled it. Now I need an equation for the distance. Well, that's a squared plus b squared equals c squared, right? Except in this case, it's x squared plus y squared is equal to d squared. And I'm trying to find d all by itself. So d isn't alone yet, so I take the square root. Square root of this, square root of that. Technically, you'd have plus and minus, but you can't have a negative distance. So there's my answer, except what's the problem? It isn't a function of x. This is pretty much the answer, except it's not a function of x. So I have to take the y out of there. And if you look at the original equation that they gave you, it says y equals x squared plus 1. So you can take out the y. This y right here. You can take it out and put in x squared plus 1. And now you got your distance alone. The square root of all that. Okay, so that was a tricky one, but it encompassed certain elements. It needed a picture. It needed an equation. I needed to put stuff from the picture into the equation, and I did. And then I needed to solve. That's the general framework for solving word problems. All right, so moving on to number 51. Let's see, we got just 2 pages left here. Number 51, limit notation as it approaches the vertical asymptotes. These are more tricky because they're coming on the inside of the function. So here's my function. I thought for a second these two are about this, but that's a totally different question. They're all three are different questions. So I need to get a little sketch for that first one. It's a butterfly, and the butterfly is moved one to the left. So here's a normal butterfly, and I got them in my head, move it one to the left, and it looks something like that. My butterfly has been moved to the left a little bit. Now I need to give the limits as it approaches this. So I'm going to do the left side limit. Limit of the function as x approaches, this time it's not approaching an infinity, it's approaching the vertical asymptote. So x is approaching, in this case, the asymptote is normally at 0, so it's at -1. It's approaching -1. And if it's approaching from the left side here, then that's from the negatives. You remember how you have to put an extra little sign right there? Some of you forgot that on the test. Limit of the function as x approaches -1 from the left. This means from left equals, when I get there, as I approach, I'd be coming in on this train track right there, and it would force me down, -infinity. Okay, let's say I was doing this picture one, part C, and I was doing the left side of this asymptote. Now let's do the right side of that asymptote. That's this part right here. Well, I'd say the limit of the function as x approaches, and every single limit you ever write looks like that. Now I just got to figure out what is x approaching. X is approaching now -3. See, that's -3. It's approaching -3. It'll never get there because it's an asymptote there. But if it could theoretically get there, it would be coming this way, and it would force me down there to -infinity. So that's an example of one of the asymptotes you can write for that one. It is +3. Thank you very much. I just read it wrong because it was covered up with so much writing. Sorry, that's a +3. Thank you for catching that. X is approaching that +3. This dotted line is hitting at +3, so my bad. All right, moving on. Number 52, is it a power function? All right, so there's a lot of different kinds of functions here. The main thing to look for is what's the variable and what's the constant, okay? It says, given that c, g, k, and pi are constants, is m a c, a g, a k, or a pi? No. Therefore, m is the variable. C is one of the constants. Therefore, that's the constant. That's the constant. And it'd be really easy to think that, therefore, the power was 2. But the variable's power is what we want. The constant is c squared. The power is actually a 1. Because it comes from the power of the variable. All right, this is your constant in this one. And therefore, that's the power. The more tricky ones here, this 9 square root of, or fourth root of x is really 9 times x to the 1/4 power. And we're going to do more with that later this semester, but you have to understand fractional powers to be able to handle this one. That's x to the 1/4 power. That's all I did is rewrite the problem. And now, since x is not the constant, that must be the constant. X must be the variable because it's not in this list here. And this must be the power then, whatever the power on the variable is. Any questions on those? I'll give a chance for Mr. M to find a mistake in this one. I'm glad you did on the other one, because otherwise people would have been at home on the video would be like, what the heck was he talking about? I'm so confused. Yes. Yes. All right, so moving on to the very last page. And they want you to write power functions here. The area of an equilateral varies directly as the square of the length of its sides. All right. On this kind, I don't necessarily need you to draw a picture. I just need an equation. So the area has got to be in it. to be an equation, right, I need an equal sign. So A equals, and it says use K if 1 is not given. So I need a K in there probably because it didn't tell me what the constant would be. So I'm going to put a K in there. And now I got to figure out what the last part is. The squares directly, that means I do not use a fraction in this. Square of the length of its sides. I'm going to call the length of its sides S squared, even though S is a terrible variable because it looks like a 5. K times S squared. There we go. If it had said indirectly, okay, indirectly or inversely, I would have put it in a fraction like this. If it had said inversely versus directly. Yes? Proportional means normal, not inverse. So proportional means directly. It's a good question. That means the same as that. Okay. And we're getting close to the very end. Number 54 or 55. Okay, 54 is the graph is a transformation of x squared. Write the equation of the transformed function. Okay, so basically it's saying it used to be x squared, now it's not. Now what is it? I start with x squared and then I say, well, it definitely looks like it moved to the left 2, right? Then my parabola went to the left 2 and it looks like it went up 1. Left 2 would be plus 2, up 1 would be plus 1. And now I just got to see if it's still the same stretch factor. If you normally go over 2, you go up 4, and it looks like it did not get stretched. So I can tell there's no stretch factor to put in here. All right, here it's asking you for the vertex. You may recall that I showed you how to use completing the square to do this. But you also may recall that I've told you that I regret that now because it was a little too mathematically challenging for some of you. And so I'm sticking with this for this last problem. I'm going to show you that x is equal to negative b over 2a. So your vertex is always going to be this. You might want to write this down. Negative b over 2a, comma, question mark. That's your vertex. And the question mark, you get that by figuring out what negative b over 2a is and sticking it in the equation. So let's find negative b over 2a here. Negative b would be negative 8 over 2a, which is 2 times negative 2. So that's negative 8 over negative 4. So that's positive 2. What did I just figure out? I figured out the x of my vertex. 2 comma what? And then I can take that 2 and stick it in this equation right here. And yes, that's a little bit icky, but once you grind that out, you'll have your y. So 2 squared is 4. 4 times negative 2 makes negative 8. Plus 16, which would be positive 8. Positive 8 minus 3 is 5. Did anybody else get 5 on that? Okay, good. All right. I'll leave this one for you to use to practice that. Again, I'd use negative b over 2a, comma, question mark. It's easier than the complete the square deal I was showing you before. Okay. Any last questions? We've covered a lot. And you now have some insights on every single kind of problem. I went through the whole packet through these series of 3 videos. If you have more questions, you have to come and ask me individually. We have a few minutes left here in class, probably like 10. And there's also help times tomorrow and Thursday. Let's see, when's your test again? Yours is on Thursday, so yeah, you could come in and get help right before you take the test and then seamlessly start the test. That wouldn't be a bad deal for some of you. Okay. Okay, that's all I got for the video for today.